Hey, welcome back to the bench. Glad to see you again. Hope you're all well. Thanks for joining. Today on the bench I decided to do something a little different, get away from the Harman Kardons, and this is a Marantz, believe it or not. And have a look at this thing. Is this ever sweet? Now this is a Marantz SR-840, and they came in different variants. They came in a 640, I believe, and a 940, and different configurations, more power. This one here, I believe it's 100 watts a channel, and it's a beast because it weighs a ton, and it is actually probably longer this way than it is wide in the front. So it's very heavy, and there's packing a lot of stuff. But if you look at the front, it is really busy, and there's a lot of stuff going on here. And let's take a look at this, because this is an interesting receiver. I think Marantz really wanted to go out on this, all out on this one. So this is the left hand side here. We've got a signal strength meter on the top here, and our computer tuner display. This is our digital display for AM and FM. We have 8 presets for AM plus FM, and these are all down here on the bottom. Actually, it shows computer preset, yeah, memory, and then 1 to 8, and then it's got 9 and 0. I think that's for setting a clock, to tell you the truth, because there is a clock in here. And we have a remote standby lamp that powers on to let you know that it's sitting in standby. And then we have a soft touch button that turns the power on and off. So this thing is powered 100% of the time, and then it switches on and off as needed. It does have remote control, which I don't have for this. It has a wireless remote, infrared obviously, and a little window here, and there's a little lamp to show when it's receiving an infrared signal. Don't know if any of that works. I don't have a remote, and you could easily find one, I guess, if you search on eBay long enough, or yeah, you should be able to find one. Here we have 2 speaker switches, A and B, and then a headphone output. Down below here we have a switch for timer. It's labeled timer. We have off, on, and set. Okay, but there's other sets here, like we can move it to this one, and that's our clock set, and then we can recall or clear. So there's some versatility within the timer. You can set a timer for it to come on at a specific time. Let's say you want to record a radio show, and you can do this. You don't have to be around. And then we have down here our buttons for memory presets and setting the clock. There's a row of LEDs here. These are your presets, I believe. If you press 1, the first one should light up. Press 4, the fourth one, etc. 2 LEDs up here to tell you what band you're on, AM or FM, and green and red. And then we have a sleep button, which you can turn on, and you can set a timer to play music for 30 minutes, 90 minutes, whatever. I think that's adjustable. And then you have a button for your clock. Here in the center we have a bunch of buttons that have the text has come off. This one here says tuning down. You can't really read it anymore, if you can see that. And then it says tuning up. And this button here says AM, but this button here is worn off, worn off, worn off, and worn off. So we don't know. These are our function switches. So this might be phono, AM, FM, auxiliary, who knows. So that's probably what that is right there. We'd have to consult the manual. Down here we got a button for scan. That's for the tuners to do a digital scan of the band, muting switch, a mono switch, and a high filter. On the right hand side we got more stuff. We have a series of 10 LEDs. I believe this is a power meter. I'm not 100% sure. But this button here, I think, is our volume up and down. And then we have a preset volume. We can have memory preset volume. We've got 4 of those. 3 of those. One's a memory set, and then there's 3 settings, 3 memory locations. So we can do preset volume and use one of these 3 buttons. They're all backed up with LEDs to show which one's which. Down here we have a loudness button and a tape selector. So you have 2 tape loops. Where is the tape monitor? Might be one of the tape monitors here. and then this one selects between tape 1 and tape 2. And then we have our dubbing switches for tape copy 1 to 2 and 2 to 1. Alright, and here we have sliders for treble, bass, and balance. And I believe they have LEDs on these knobs, so they should be lighting up. There's a lot of stuff going on here, and Marantz really tried to pack it in, and I think they got a little carried away with the button madness. The buttons and LEDs, all these function buttons are backed up with an LED, so there's lots of lights, lots of things going on, lots of programming. I think back in the late 80s, or sorry, early 80s, when this thing was spawned, I have a feeling this was just one of the engineers' webs as far as going digital. Condition wise, it's very dirty. It's missing a glass window here that covers up this display. I think it got knocked off, but that should be replaceable with something. I could probably cut glass to fit in there and replace that. Obviously the remote's missing. And another thing is the script has come off a lot of the buttons from wear. I don't think this was thought out too well. They could have had these buttons etched with the script instead of just having it silkscreen on top. On the back we have gold-plated inputs for phono, which is a nice touch. We have input for CD video, which would be our auxiliary. Tape loop 1, tape loop 2. So that's all we have for inputs and outputs. There is no breakout for preamp, power amp. We have antenna inputs and AM input. There's no bar antenna, so we'd have to have a long wire or a coil for any AM reception. 2 sets of speaker outputs, 2 courtesy outlets, and then a main fuse. This main fuse says 5 amps. Let's check it. Fuse holder's broken too. And what do we got here? We have 5 amp fuse. Okay, so we're good. I have no idea if it works or not. Never plugged it in. It's been sitting here for probably, well, I'm going to say more than a decade. Don't know where it came from. I don't know its history. I know nothing about it. I don't know if it works or not. So let's maybe plug it in and power it up and see if we can get some. Well, let's look inside first. Alright, screws are out. Let's take the lid off. Looks fairly clean underneath. No heavy smoke. And look at this beast. This is quite an amplifier or receiver. So this is amplifier's power, huge power transformer here in the middle, and then a power supply board here. It looks like it has protect circuit. You don't see the relay. Well, the relay's back here. But that could be a power relay. This thing does have standby power, so it is going to be remote turn on with a relay. So yeah, there is a transformer here and a relay, so that's standby power back there. But I don't see speaker relays anywhere. Oh, speaker relays on the speaker board, speaker output board here. There's 2 relays. Okay, so they're switching on and off each channel with a relay. Here we got a big tuner board. Lots going on there. And then what it looks like underneath, there's a board that looks like it's probably doing audio. Multiple boards here on the front that are stacked. One here, one underneath it, and then one underneath that would be on displays, for the displays and buttons. Lots going on here for sure. There's a small board here. I bet you this is the remote control receiver. Power and speaker switches are on this board. Another board for the remote. Yeah. This thing is just loaded with caps, and I bet you they're all dead too. Rubicons. I'm going to pull the bottom off, have a look as well. Okay, on the bottom we have an access panel that says AA batteries ×4. With that little screw here we can remove. I hope there's no batteries in there. Oh yes, look at the dust falling out already. So this is not a good sign. Got heavy corrosion. Oh, okay, no batteries, but we do have corrosion. Need to clean up. Alright, so we have one big access panel here, and then we have an access panel over the power supply board. And that's pretty much it. The rest is punch for ventilation, transformer, and then we have a switch here that says scan step. 10 kilohertz or 9 kilohertz steps for AM, 100 kilohertz or 50 kilohertz steps for FM. So that's for setting up your tuner. And it looks like this little panel can come off as well for the front. Let me take some panels off. Alright, removing all three access panels. This one here really doesn't get you any access for anything. Bottom of the power supply board though gives you full access. This panel here removed, and it's for servicing your power supply. This panel here is covering up all the audio section. What do we have here? Tape monitor switches, and our tape selector switches are here on these long sticks. And then this would be phono stage, I believe, and the TC9151. I believe this IC is audio switching IC. It's an early one. And so this is all audio. This is our audio inputs, audio and outputs, and we have a little local regulation here, positive, negative. What do I want to do with this thing? Well, as little as possible, to tell you the truth. I was kind of hesitant to even open this thing up because it could be a real big can of worms with regards to replacing capacitors and getting things to work. It might work completely fine, I don't know. We could plug it in, test it. Everything looks intact and complete, and I could check fuses, and then we could power it up. But this could turn into a huge project. That's probably the reason why it sat on my shelf for so long without anybody touching it. It's just one of those things that you really don't want to open up if you don't have to. But let's see what we can get for noise out of this thing. Okay, let's go for it. And up to 4.5 watts. We have the letter E in our window. Clock set. Okay. I see what. Okay, so if I want to go 12:45, 1, 2, 4, 5, and then set. I think that's it. Set. There's our clock running. It seems to be working all right. We have our remote standby light on. Let's turn this thing on. Button's not working. I'm getting no response. Could be a bad button. So that's our first issue, is it won't turn on. Looks like somebody's been in here trying to fix this. Okay, it seems to be working. Turn it on at 155, and then it wants me to select my input source. So let's go AM. And the station. Okay, let's go with station number 4. Alright, I think we're ready. So I think all I have to do is put this on and go recall. See if it turns on at 1250 like I set it to do. Get ready to unplug if things go ugly. No, it's not turning on. But before I remove the front panel, I have to remove these switch actuators. They come out easy enough. Otherwise, I will be bound. Okay, so I should be able to remove the front now. Alright, let's have a look at the block diagram for the Marantz SR-840. So this is it in a nutshell. This is the entire receiver, and let's focus in on one area in particular, which is the microprocessors. So Marantz really went all out when they designed this thing. I think they were trying to one-upsmanship everybody else in their thoughts and in their design. They put two microcomputers in here. Both they do different things. Microcomputer number 1 handles the volume up down. Microcomputer 2 has a more intense job. It handles the clock functions. So this computer here handles the frequency, time, and display. So this is your clock and AM, FM frequency display. It handles the memory for the stations. It handles some of the remote control functions. So here's the remote control transmitter, receiver, logic controller, and then the signal comes in and it's fed into the key matrix to control the receiver through the remote. And then we also have the key matrix outside of the remote function that tells the microcomputer what state it should be in. The microcontroller turns on and off the main power relay, okay, through here, and then which in turn turns on the mains transformer. You can't see that mains transformer power supply for the rest of the unit. Alright, I think we're together enough that we can plug this in, and right away it turns on. Let's see here, what do we got? Well, we're powered up, and if I push the button, it shuts down. Push it again, comes back on. Everything seems to be working. And yeah, we got our AM, FM. I don't know what that is. What are we going to do now? I think we're going to I have the relays out, so we can't test it for audio. But when I get the relays back in, let's power this thing up and let's give it a test and see what other work it needs. I have a feeling both amplifiers are okay. We're drawing 38 watts here while we're powered up, so I'm assuming both amplifiers are okay. These controls here will probably more than likely be noisy, so they might have to come out. So yeah, let me get the relays back in, and so we can test for anything else that's wrong. So I don't think I've ever seen a relay this bad. I think this is probably out of the B channel. Where are we here? Right there. So let's turn this thing on and see how bad it is. So we got about 800 kilo ohms, 750. Keep clicking it, it doesn't get any better. That's terrible. Let's try the other side. Okay, here we go. Well, this side is 500 kilo ohms. Yeah, that's terrible. Look at how bad that is. 700 kilo ohms. So this must be the second set of speakers, and it's probably never been used. Let me try the other relay. So let's try this relay out, if it's any better. I'm assuming it would be better. So let's try this. No. It's 900 kilo ohms. Almost a mega ohm on the contact resistance. What is going on with this thing? Okay, contact's this dirty. I'm going hardcore. I'm going 2000 grit, and I just cut a little strip of paper, fold it in half so I have abrasive on both sides. And we're going to go hard on this one. Okay, close the contacts and just give it a workout. Flip it over. Let's try this side. So that should bring everything back. Do this one while I'm here. These are actually, well, they look like they're copper buttons, but they're not. They're copper buttons with a silver cap, and it's not a plated cap. It's solid silver, but it's bonded to the copper pellet. So that should be good. Let's test these one more time. Let's see how much of an improvement. I don't think it's perfect yet. I think we still have a ways to go, but we'll see how much closer we are to having a good set of contacts here. So what do we got now? 99, 97. We're still way all over the place. 35, 35, 60. Okay, let's try the other side. Yeah, we're not there yet. I don't know if you can see the stuff the sandpaper took off. I probably would have been better off using 1000 grit or maybe 1500. This is pretty fine stuff. So what I'm going to do is I'm just going to clean the contacts with zero residue cleaner, just to get rid of the dust that came from the sanding. I'm just going to spray them down, clean those contact faces. Okay, and then I'm going to give it another shot with the paper. And we're going to keep doing this until we get a good contact resistance down in the around the 10 milliohm range. Alright, here's a look at how I ended up, and it turned out pretty good. As from 700 or 800 kilo ohms, this is what we got now. Just give me a sec, I'll hook it up. About 8 milliohms, 7.5, 7.5, and the other relay is the same, so I'm pleased with that. That's what you get from a relay that sits for decades without being used. The contacts will corrode and becomes useless. Alright, I got a pair of speakers hooked up. Let's do our first test. First initial test. This thing hasn't been powered on in decades, I bet. Let's plug her in. Okay. Bring it on. Our volume control. Turn this down. We've got 10 LEDs here telling us volume. And we are on FM. Speaker A. Looks like we have a problem, Houston. My tone is coming through. We have no FM. See if we can find a station. Turn this tone off. Getting anything through FM. Muting. Let's try. Ooh. It's all locked up. Turn it off. It's not switching, or the lamps aren't following. This thing might just be a basket case that can't be fixed. Let's try this. Turn it on. Let's go to CD. These buttons are there we go. Okay. That should be our tone. It's not coming through. Seems we have a problem. Our function doesn't work. We can select any of these. We're not getting anything through our function switch, it seems. And we're not able to electronically select our inputs. And our volume control has no effect. So I'm wondering if our second processor is faulty. Our second processor handles the volume control. And I think that's it. Preset memory volume. Let's try this. Reset. Seems to be holding memory. Let's go up here. Memory preset. Okay, so preset memories work, but the memory function, the memory does not. We have no input switching. Well, I gotta tell you, I'm not impressed with this system. It's got deeper problems than what I first thought. Don't know what to tell you. I think it's scrap metal now. I'm going to investigate further about these function buttons and this volume. The volume up and down is working because we have an indication here on the LEDs, but there's no volume control. The computer's not turning the volume up or down, and I don't think it's a connection issue. I've had this thing apart together about 10 times. So I don't know what to tell you guys. I think we're pooched. I don't know what's going on with this other processor. It doesn't seem to be working. And that's something I'm going to dive into next, I think. Alright, so it's the next day. I had a sleep on this and I think about it. And I'm wondering what to do with this pig. Do I abandon this project? Do I just say throw the hat in? You know, we still have no audio through it. We have no control over the volume. We have no control over the input selection. Probably a few other things. The tuner, I don't think the tuner's working. I don't think it's producing any signals. You know, I did scan through the band. I didn't see any signal strength lights or anything like that. So I think the tuner's dead as well. So what do I do with this? Do I just scrap it? But here's the reason I don't want to scrap it. Right here, everything you're looking at in that field of view is the power amplifier. This thing is massive. It has two massive amplifiers. They have tandem outputs. Everything's self-contained within this area. We have our input signal here on this cable here. That's our left and right coming in. We have our power coming in through the transformer. We have our speaker out through these two lines, the orange and I think it's the blue or white, or I can't remember. But speaker out, signal in. This could be all removed and used as an independent amplifier, and with little modifications to anything else. It is a self-contained, say, assembly, and this should have some good things about it. It's got a lot of power. It's you know, it's a Marantz. I don't know. Making it a Marantz name doesn't make it any more special than anything else, but this could be used as a nice base for a power amplifier. But we got a lot of other things on the go here too. So like I said at the start of the ramble, I had to think about this last night, and I think the problem we're experiencing here is maybe power supply. Maybe we have a dead power supply and all of these circuits here are not being fed with power. Obviously the microprocessor for controlling the volume is working because we can up and down it, and the LED display follows and goes with it. So you can turn it right up to max. And I have a feeling the microprocessor is working there. We do have control over our input selection, but those control signals aren't getting through to the chip that's doing the switching for the audio signals. It doesn't seem like that chip is hearing the signal, or maybe it's dead in the water and it's just not doing anything. So yes, we are getting control over the systems, but those control signals aren't getting through for whatever reason. So I'm going to start checking power supplies here. I have a good feeling about this, so stay tuned. Alright, here's the block diagram for the electronic volume control circuit. So we have our processor. This is a different processor than the one we were working on. This is an LC6505 B-665, whatever that means, I don't know. But our switch is up and down, and our volume level LED, this is working because we were able to adjust it and have the level indicator move with our buttons. Okay, so that all works. Memory preset, I tested that, and you saw it yourself. I can store memories in the presets and we can recall them. But this part here is not working. This is the TC9177P electronic volume control chip. It is not doing anything. So that makes me suspicious that we have a power issue supply problem for this chip. Here is the TC9151. This is the analog function switch. So here we can switch between, all of these switches are controlled by this logic. And this could be our tape monitor, CD, phono, tuner. It all flows through this chip, and it's all controlled by the control signals that come from the microprocessor. Okay, this also is not working. That's very suspicious too. So here's the diagram for this board that I'm going to start troubleshooting, and these are our two control chips. This one here I believe is our volume 405. Yeah, this is our volume control. And this is our input. So I'm going to check for voltages on these chips, if they have supply voltages. Let's start with the 405. Now it should have, I don't know if there's a ground connection here. Where is ground? Ground is this black line. Yeah, ground's on pin 6. So if we have to, we'll have to trace out the ground too. But pin 1 and pin 20 is our positive. Pin 1 is negative 15, pin 20 is positive 15. So let's look there first. I don't know if I can get this all in frame, but this is our chip right here. This is IC405. Okay, and the meter you should be able to see, I hope. Yeah, okay, so powering on. Here's our power. Oh, did I see a spark? I thought I saw a spark in this area, but I might be mistaken. So let's go for pin 1. Should be negative 15. Or actually, let's go, yeah, pin 1. Pin 1 is up here. So what does this say? We've got 350 millivolts on pin 1. Pin 20 should be 15 volts. Let's see what we got. Oh, it shut off on me. What's going on here? Okay, sorry about that. Let's try that again. Pin 1 should be negative 15. We got 600 millivolts. That's not correct. Pin 20 should be positive 15. And we got positive 15. Look at that. That's our problem. We're missing a power supply voltage, negative supply. This looks suspicious to me. This cap's been changed. This is a Mashishita cap here in the middle. Let me zoom in, you can see it better. So all of these other ones are Rubicons, okay, except for this one, this outlier here. This is a Mashishita cap. So somebody's been in here replacing caps. This cap might have died from heat. Let's see here. It's turned on right now. And I'm getting heat in both of them. This one's not so much. This one, 502. 502 is the negative regulator, I think, and 500, Q500 is a positive. This one feels a lot cooler than this one, but I bet you that's where our problem lies, somewhere in here. We're not getting negative 15 regulation. So let me trace the schematic and figure out where my test points are. I can probably test on one of these caps here, and I'll bring you right back in when I find something. Okay, apologies for this. This schematic I printed out, I expanded it as much as I could to fit the page, but it's still a lot of detail on here. So my negative 15 volt pin here on pin 1, if I follow this trace, it goes to IC404 on pin 4, and follow it through. It goes up here, around over here, pin 40, IC401. Okay, and then it goes down here, and then it goes to pin 4 of IC403. Okay, there's a third chip that supplies. Okay, and then it goes through and it supplies, looks like through 100 or 10 ohm resistor. Goes through to IC402. That's, I didn't check that yet, but it's obviously missing. Where else are we going here? We're going up around here, pin 4 of IC406, I think that is. I'm not sure, I can't really read it. And then it comes down here, over here. Let me do that again. 1, 2, 3. Bang, to a connector. So it goes off board. So this negative 15 volt supply isn't even generated on this board. It's generated on the another one. And that's JP530. Right here, I can read that. Okay, so let's look where we're at. So right here is jumper 530, and this cable runs to the top of this. Let's flip this around, have a look where it goes. So the cable for jumper 530 comes here. You can see it there, I'm wiggling it. And it goes down. It's this wire. This wire going to the main power supply board. So our negative 15 is on this power supply board. So we're going to have to do our troubleshooting here. Okay, so our negative 15 volt supply from the, let's call it the audio board, follows through and comes through on JP530 right here, and it enters the board. It's on pin 6. Okay, this pin here, and it even mentions here negative 15 volts. You can see it. So this transistor here is a pass transistor, and it's passing negative voltage through. It's a PNP, and it's coming from this bridge rectifier. Look at that. And it's got its own filter cap, so it's its own little independent supply. Comes from oh, and look at this, fuse resistors, R713, R714, 1 ohm fuse resistors. And this would be our transformer here, transformer winding. Yeah, so this looks pretty easy. So let's see where we're losing our negative voltage through this chain. I bet you it's one of these buggers. Okay, I don't know if you can see them in there. Here's our 713. It's really difficult to see. It's all buried. And here's our 714. So I got it continuity mode. Let's check these fuses. If I can get in here. That one's good. Oh, that one's not good. 714. Oh, hang on. It is good. They're both good. So where's our fault? Here is, I can't see, everything's in the way here. Here's 702. This is the pass transistor right here. So what's going on here? We got a wire and there's a Zener diode. I wonder if that's shorted. Can't get in there. I can't get in there with these wires in the way. I'm going to have to do this off camera, and then I'll bring you back in and let you know what I find. But for whatever reason, we're losing our negative 15 volts here in this little circuit right here between these two fuse resistors and that transistor. We have no output. Alright, I hope you can see all this. So this thick trace up top here, this is our ground. So if I touch it to there, we should get 0 volts, which is correct. And this is a capacitor right here. This is, I believe, this is capacitor 713. It should be a 470 at 35 volts. So if I check down here, I got negative 28 volts coming off our bridge rectifier, fuse resistors, everything's working up to this point. So we're getting a negative voltage, and then it goes to this transistor. And this is the collector of the transistor here. So if I touch here, I'm getting a negative 28 volts. And then here, this is the emitter. This is our line going out to the other board. And if I test here, I'm getting 550 millivolts. Notice this is less than what I measured on the other side. I measured 600 millivolts, so it's dropping. This voltage is less than what it was on the other side. So this millivolts is getting pushed through the chips back to this point because we have no negative voltage here. Okay, so we check the base. Where's the base? Right here. 0. And that's a Zener diode here. So the Zener diode should be tied to ground. I bet you 100% that Zener diode is shorted and it's shutting the supply down because we're getting nothing across the Zener diode. It's complete. Let me turn the power off, kill the power. Let's put it on diode mode and let's check across that Zener diode and see what kind of millivolts we get. We probably get 0. Exactly, that Zener shorted. So let's change that out. That should be a 15 volt Zener. D712. I have to go and check, make sure it's a 15 volt. Might be something else too, I don't know. And a quick check in the service manual. D712 right here is a 15.7 volt Zener half watt. So that should be very easy to replace. We'll find one, put one in. And I don't have 15.7, I have 16. That's the closest value. Closest standard value, so I'll take one of these. 300 millivolts shouldn't matter. It's not the space shuttle, so that should be alright. I guess it helps if you turn your iron on, eh? Alright, take 2. Where is it? It's over here. Here it is. Okay, can we get this out of here? What an awkward thing. They got wires piled on top and caps in the way and okay, I think got it. You little bugger. Alright, see if I can get this in here. That's quite a squeeze to get this in. Let me see if I can do this. I'm gonna have to use tweezers or something. So it looks like the band goes down. This might be tricky. Got one lead in. Get the other. Would be great. Come on. Can't see anything. That's the problem. Where are we with that other lead? Way down here. Did I get it? No. Can't see. Is everything in the way? I buggered that up, didn't I? Let's try this again. Maybe if I try the bottom one first. Ugh. Awkward angle, camera in the way, no light, things are blocking. Okay, I got the bottom one. Let's get the top one. Just stay there. There we go. I got it. Get in there. Push it home. Okay. Good enough. Gonna solder that in place. All right. All right, I got a good feeling about this. I think we're getting progress here. So let's plug it in, turn it on, and let's turn down the volume. We don't want to blast everybody. Let's turn it down. And let's select CD because that's where my tone is. Turn on speakers. We still have no volume control. What is going on here? Yeah, there's no change. I wonder if we lost our, we still have our supply voltage. Let me check one more time. We might have a short on one of those Jelly Bean op amp chips that is pulling down the negative 15 volt supply. If that's the case, we can fix that too. So let's go see here. Where's pin 6? Pin 6. Yeah, we got what? 15 volts. It's supposed to be negative 15. No, we got no change. Maybe that transistor's booched. We have no voltage across that zener still. So let me check with my continuity. Do we have a shorted zener now? Shows 1 ohm almost. Let me check these fuse resistors. That one's good. That one's good. Maybe we got a bad transistor. You can see down in here. It's just a jumble of stuff. I'm checking between ground and I wonder if that transistor's bad. Base. See, that's the zener. This is the that's ground. No, this should be ground. For whatever reason, that zener's shorted already. Alright, here's the zener I pulled out. Have a look at this. Open. Come on. Open. 739 millivolts. This zener's okay. But look at this. The zener is paralleled with a capacitor. 715. 100 microfarad at 16 volts. What do you want to make a bet that cap is shorted? Usually it's the zener that goes first. From heat they die. But look at this cap. This cap is suspect now. Still not getting anything here. This is still business as usual. Let's change this cap. Let's pull it out and test it. Alright, so here's the zener. Okay, and this trace here, you follow it around, it goes up to ground. Okay, so that's our ground. I was correct. The meter did show it right. And this is showing correct as well. It's a little bit of a voltage here, so it's not a direct short. This is our base, and if we follow it through this, here is our capacitor. So let's remove that capacitor. It's really unusual to see a cap short like that. But hey, anything's possible in electronics outside of the, or I should say within the laws of physics. And all right, we're loose. There's the bugger. Now, before I go any further, did our short go away? Let's check. I have a feeling it did. Yes, it's gone. Short is gone. And our little cap is the problem here. It's a little Rubicon. Everybody loves their Rubicons, but they're not always the best. Shorted. Shorted. 100 microfarad, 16 volts. Alright, let's get a new one in. I'm going to upsize this to a 25 volt cap. This is a high rated cap. It's 105C, 10,000 hours lifetime rating. Put that in. Alright, so this little mark here is negative on the bottom. So we'll put our negative down. Come on. Alright. Now I have a feeling, well, if we are going to get this thing working, I know we will. But I'm going to come in here and I'm going to replace all the rest of these caps. If we got one that failed like that, and these old Rubicons, we're gonna recap this thing for sure, and make this 100%. All right, one more test. Let's plug her in. I don't like that it comes on when it's plugged in initially, so let's turn the volume down. I didn't hear the relay click. Let's turn on let's turn this off, turn it on. We're not getting a relay click now, so maybe we got other problems. No relay click. We're drawing 33 watts. We got no relay click. Okay, so we got another problem on our hands, and that is our outputs of our. Let me check for DC going into the amplifier, because that could be a big thing. So let's check here. Left channel 0. Right channel. How does this work? CD. Oh, we do have a relay. Our volume's working. Look at this. Sorry about that. Okay, so we have all our volume, and we have our switching, phono, AM. We should have something on FM. No scanning. Okay, we're making progress here. We got our audio through our volume, input selection. Tape monitor is not working. For some reason we get no tape monitor. AM. We got no sound on our tuners either. That's another thing we need to track down. Muting's off. You should hear hiss. Let me see if I can find a station here. No. See, it gets all weird on us. See, now it's locked up. FM. Yeah, phone always shuts it off. Let me try killing power. Do a master reset. Okay. Okay. All right. Muting. Yeah, it gets up into a locked up state here and it just doesn't know what to do. What I'm going to do is I'm going to check for voltages around the tuner to see if we're even getting voltages in a tuner. It might not even be alive, it might be dead. So that's maybe the reason why it's locking up here and we're not getting any noise, any response. So let me do that. Yeah, just as I thought, we're not getting any power to the tuner board. I'm seeing here, I'm checking on these chips. Let's go for this one, for example, the LA3410. Go around the, you're not getting any voltages, so there's no power here. Everything's dead. Oh, we got 3.8 volts there. It should probably be 12. Nothing. Absolutely nothing. Yeah. Interesting. So we got more troubleshooting to do. Alright, so I went through, this is the tuner board here, and I identified the power pins on a lot of these chips. I went through and tested, and there's dead. There's no power on a lot of these chips. So tracing these lines back to the different boards, this one here, this connector JP160 on the bottom here, this flows back to the audio board. And if I look on the audio board, all the roads lead back to these. So that's where I'm at right now. I'm checking voltages here, and I'm getting some voltages, but then here I got nothing. This Q503, I think Q503 is part of my regulated supply for the tuner. And looking at this, here, I'll show you a thing. Right here is a Zener diode. So I check across the Zener diode. I'm in diode mode. We got a dead short again. And then we have another one of those goofy 100 microfarad 16 volt caps in across the Zener. So is it the Zener or the cap? So I'm going to have to take this apart here and figure out that's not correct. So this is probably our reason for no tuner voltage supply. Yeah, this board has to come out because right on top of it is the tuner board, and they're sandwiched together back to back. So I got to take this board out. It's pretty easy. I think a few screws, it should just pop right out. Okay, I don't know if you're going to believe this, but this is wild. I pulled the cap out first because I suspected the diode last time, and look at this, cap is completely shorted. Dead short. Another Rubicon 100 microfarad 16 volt cap. Dead. This thing's full of Rubicon caps. Okay, let me pop a new cap in there. Let's see if we can just get this thing going. I mean, I'm just running out of patience with it. It just seems to be one thing after another. And hopefully this is the end of it. So, wish me luck. Alright, new caps installed. Let's do a test. Another test. Plugging it in. Let's turn the volume down before I turn the speakers on. Alright, so we're on FM. Oh, listen to that. Yes, we have interstation hiss. Scanning. We don't have an antenna. Let me connect one. Signal strength. Awesome. So there's CD. We still don't have tape function though. I keep pressing this button. No tape function, but we have phono. Let me turn the volume up on the phono. Yeah, and I think the phono stages is working because I can hear the hum and hiss. Alright, I think we're in business. AM. Let's try. We have no antenna on AM either. It's working. It's picking up noise. Yes, I think we have a fully functioning receiver now. Still not getting the FM.
It's a victory Tuesday. The Toronto Blue Jays, of course, advancing to the World Series. I am hyped about it. I was much more hyped last night. I'm still kind of coming down from that high last night of watching that.
Okay, shut that off. I am happy with that. Let's talk about this a bit. Okay, so a lot of things are working, some things aren't working. Like we still have no stereo separation. We've got no stereo signal. The volume presets are all working. The memory presets are working. I can go through the memory presets I just put into it. We still have no tape monitor function. I don't understand what's going on there. Might be another shorted cap, I don't know. But what are we going to do with this thing? Like, I'm looking at this thing. It's loaded with these blue Rubicon caps all over. I think what I'm going to do is recap the power supply and amplifiers. I am not decided about the tuner yet. I'm going to see if I can get stereo on the tuner by maybe an adjustment or alignment. And I also want to go through and replace the caps on the audio board that's underneath. There's an audio board there with power supply, so I want to recap that one as well. And maybe after I do that I'll get my tape function back, but who knows. What's the plans for this thing? I don't know. I don't have any plans for it other than just to make a video and make it come alive. It was a bit of a challenge getting it this far, and I really enjoyed working on it too, as one problem after another. But now that we have it going, is anybody actually going to use this thing, or is it just going to be sitting on a shelf? So let me start with the recapping and see where we can take this. Yeah, I like this. Another thing is these controls are nice and clean. I don't have to touch these sliders, which is unusual. They're all working good. So yeah, I think it's a good one. One thing that I'm going to do is I'm going to cut a hole in the back and I'm going to put a hard power switch in, just so we can shut the mains off when this thing's not in use or you go on vacation. I don't like that it draws power all the time when it's plugged in, so I think right here there's some French here I can cover up with a sticker that says mains power, and then put the switch right beside the courtesy outlets, something like that. This switch handles 10 amps at 250 volts, so it's good. Yeah, that's one mod I'm going to make. Well, it looks like I found another shorted cap. This is another Rubicon. This is a 47 microfarad at 16 volts. When I pulled it out, it measured, originally it measured 4600 microfarad or something. It was shorted. And then it went down to 50 microfarad. Now, as you can see, it's climbing back up again. It's closing up and shorting. And the value just keeps rising and rising. So It's another bad cap. And this is on the audio control board. There seems to be a lot of bad caps here on this in this receiver. If you own one of these, I think it's time to pull all the caps out and replace them. Tell you the truth. Look at how it's climbing. So these orange Rubicons, these are the Rubicon version of audio grade, I guess. The blue ones are just regular orange audio. I don't know what the codes mean. But anyways, these are all testing. These are 4.7 at 25 volts. They're all testing down around 4 microfarads. Some are around 3.8, 3.7. So they're getting pretty tired. They're getting dried out. So I'm going to replace them. Got some Elnas. I'm going to put them all in. And then these are all in audio path. So these are for phono stage, input switching, and electronic volume control. That's where these all came from. Alright, tuner is done with the recapping. I got them all. I didn't find anything bad, nothing to report. Everything was normal as far as that goes, but I'm not taking any chances with these Rubicons and clean the back. So this is all ready to go back in, and then it'll be ready for alignment. I happen to think the alignment is out on a lot of this. Interestingly enough, the service manual says this has an AM stereo decoder in it, and I don't see it on this board. It must be somewhere else hiding. And in the service manual they have the pinout for the chip. It's an MC13020 Sequam stereo decoder chip. And yeah, I don't know where it is. They're hiding it somewhere. But it'd be interesting to know that this thing is stereo compatible. Alright, servicing the power amplifier is pretty easy. Four screws, 2 on this side, 2 on this side, and then there's a 5-pin flex connector here that you can unplug. This here from the power supply board. Cut some cable ties, and then you can just lift the amplifier module right out. And if you want, you could disconnect these other wires. The white wires are speaker out, and then the gray and oranges are positive and negative voltage rails. These 2 white wires go to a thermal switch that's hidden underneath here. I don't know if you can see it. There's a thermal cutout and over temp sensor. I need to remove this board to inspect it for cracked solder, so that's why I have this out. There's no caps on here, just a matter of inspecting and cleaning and making sure it's 100%. So I'll get this done, do the other side, and then I'm done. Everything's been recapped. This was a chore, doing all the microprocessors and stuff. 3 layers of boards, I think 4 layers in some spots. But it's all done. Tuner's done. Didn't find any bad caps in any of that. Only found that 1 shorted cap on this board. And no, 2 on this board and 1 on this board. There's 3 shorted caps total in this thing that prevented it from working. So I think we got it all. Okay, so I cut a hole in the back here. I don't know if you can see it. This is going to be for the power switch. So this is the power switch. So I just drilled 4 holes in the corners. I measured it out, scribed it, drilled 4 holes in the corners, and then used a abrasive disc on the Dremel just to cut it out. And I think that's going to be its final resting place there. And I'm looking at just putting it in with the line cord. This doesn't look like it's a factory job here. And I'm looking at this. This is polarized. And it's definitely polarized, but this is not. So you really should have a polarized plug if you're going to have a polarized outlet, just to keep the neutral and line separate. This does not look factory at all. Looks like somebody gobbed that on there. So maybe I'll change that power cord as well. And then I'll put the power switch in here, wire it all in, and we'll have a hard power switch on the back. Alright, so I got a new power cord installed, and it's polarized now. You can see, polarized plug, fits into the polarized outlet. Now, the reason you got to have a polarized plug with a polarized outlet is If this is non-polarized and you plug it into the outlet either way, there's no guarantee this is hot or neutral. This one should be hot, this one should be neutral, but if this plugs in upside down, this one will be neutral and this will be hot. Now, what's the big deal? Well, if anybody plugs any kind of appliance in here that relies on that hot and neutral, you can actually get an electrocution hazard. So that's why we have to follow through. If you're going to have a polarized plug, you have polarized outlet, and then the power switch is there. This is going to be good for if the microprocessor glitches. We can do a hard reset, shut everything off, turn it back on, and clear it, and everything's wired in. And I can now put my board back on so we can connect the wires. This is orange, blue here, and gray. I'll solder this all back up, put it all together, and then we can move on to something else. Got the back panel on, and I have the standby power supply board connected. And this screw here is just stripped, so you can turn it all day long. It's not going to tighten up. So what I did is I just added a ground wire, and I'm going to ground it to the chassis here, just so this connection is reliable, because there is no other follow through to the ground from that. I don't know, Marantz should have had an extra lead for a ground wire. This is fairly easy to take apart. You have to desolder the transistor leads from the board. Do that from the top, and then once they're free, you can remove the screw for the stabistor, varistor, whatever you want to call it, and there's a clamp that clamps this transistor down onto the heatsink, and then you can flip it over. You can see, I don't know, some of these joints aren't the greatest. I'm going to resolder a lot of this board, especially on these driver transistors. This one here looks like we got cracks. This one here not so bad, but I'm going to resolder everything and then clean it and put it back together. I think the paste is good. It's still, transistors are tight, snug them down. Okay, I'm beginning to believe this thing is cursed and needs an exorcism. This is another cap I found that's shorted. It's showing, well, 62,000 microfarad. And it is a it's a 100 microfarad 16 volt cap. But this is a new cap I just put in. I'm going to show it to you. This is a brand new cap put in, and now it's shorted. But this is a 16 volt cap. The schematic calls for a 16 volt cap, and this is filtering the output of the 15 volt regulator, so it's just 1 volt above what it's being used at. So for whatever reason this cap's shorted. I'm going to put a 25 volt cap in, and hopefully this is the end of it. And the curse continues. So doing another power up after replacing that first cap, this one might pop. What is going on with this thing? This is a 220 at 16 volt. Blowed it up, and yeah, this is not right. I did check the polarity of all these caps, and they are correct. For whatever reason, we're getting over voltage or we're getting reverse polarity. So let me keep working on this. It is that was quite a bang too. This one really went pop. So this is C504. Let's go see what C504 does. Okay, C504 is right here. It's a 220 at 16 volts. Look at that, another 16 volt cap. And that's connected to this line here. This one here that goes over. And that goes out connector JP530 pin 1. That's our plus 15 volt supply. Here's a look at the other end of JP530 pin 1. Comes up, output of the regulator 701, And this cap blew as well. This is a 15 volt, 16 volt cap. So maybe we're getting a short here across this stupid regulator's failed, and we're getting this full voltage of 26 volts through here. Maybe that's what's going on. Let me check that. Okay, what I want to do first is disconnect this cable 503 here. We don't want to be putting over voltage into our other board. We'll blow up all these chips on here. Maybe it's too late already. Maybe we already did that. So, oh God, I hope that's not the case. So let's check the voltage of this. And let's plug it in if something else doesn't pop right away. Alright, what do we have here on the output? We've got nothing because our receiver's dead. We need to turn it on somehow. And with this cable unplugged, it's not going to come alive. Let me pull that regulator out. I happen to think this regulator is pooched, and it's passing unregulated voltage through, which is burning everything out. This thing. Why is it doing that now? It didn't do that before. It was working fine. Alright, I got it to power up. So let's check the voltage on pin 1 in this cable. Got the voltmeter here. What do we have? 15 volts. What the hell is going on? That regulator is working. But why would this cap blow up? It's a brand new cap. Let me pull this board out and check. I don't know what's going on here. What do we got in these other pins? 28 volts. I don't know if that's right. 21 volts. 16. -3. -15. I'm wondering if all our voltages are correct. Let me pull this board out and check what's going on. Maybe we had a solder bridge or something on here that's really messing things up. Okay, I think I figured it out. This is pin 1 here. This is our positive 15 supply. So if I follow the trace down and up, where did I miss it here? Follow the trace. It goes through. This one here is the cap. Something's wrong here. Pin 1 goes through this transistor. That's not what the schematic said. But this cap is mounted backwards. If this is ground here, this is all ground, that it should be negative. But on this side's marked negative. And that is cap 504, so that should be the right one. Cap 504, positive, yeah. Alright, so here's the lowdown. This is what I found out so far. When I first powered, I did the recap and came time to power it up first time. This cap here shorted. Now this was a 100 microfarad at 16 volt. It didn't like the 15 volt power that was feeding to it, and for whatever reason it shorted. Interestingly enough, this regulator has been replaced. It is now an ST unit, and it's got a date code of 1998, so it's been replaced sometime in the past by a technician. This cap was shorted, so I replaced it with a 25 volt cap. As far as it is oriented the correct way, the negative is facing down, so that's all good. Now power it up, we got 15 volts here, no problem. This cap 504 blew up on me. Now if you look at it, the negative is facing this way, but if you look at the board, you see it's marked wrong, right? So that's why I installed that cap backwards, because I was going by the mark on the board. If you look at all the other caps, they're all facing the same direction. All the negatives are facing the same way, including this one now. But before, this one was backwards, and it sucked up a lot of current and then it went pop. So as far as I can tell, everything's working now. It powers up, and so let me put this thing back together enough, then we'll do a test again. Okay, so it's back up and working again. I really was sweating there for a minute because when you have caps exploding in the power supplies and on other boards, I started thinking, do I have an over voltage situation here and I'm blowing chips as well? But thankfully, no. We had one bum cap I installed, and the other cap was installed in reverse. So now that that's sorted, everything's working now. And even I'm pleased to report, the tape monitor is now working, and I can switch that on and off. Before it was doing a loud click. I think there was some DC in there, and I did find another shorted cap in that circuit. So I think after I moved that shorted cap, we got it back. So everything's good now. Okay, so next I want to do some bias the amplifiers. And I'm reading the service manual. It's not really clear on how to do it. Well, it's clear on how to do it, but it's not clear on... It's really not clear if I'm reading across both emitter resistors or just the one, but I think it's both. So I'm going to try and set this up so you can see it. Just leave this here. You can read that? Sure can. So the spec is 13 millivolts. Let's see what we got here on this channel. We've got 18.4, which is a little high. Let me turn off our source. Turn it to CD. And turn off our speakers as well. Turn on some lights, and then let's get a little adjustment device. I'm going to treat the potentiometers with a little bit of this F100. Do both of them here. Okay. So this is our power consumption. And let's try and adjust this without blowing anything up. Okay, I want to work this. Alright, so we want 13. It's been on for like 20 minutes now. 12. So this adjustment is... It's fairly easy to adjust. It's not very sensitive. Alright, on to the next channel. Gotta say, this is one of the easier ones to adjust. What are we at? Oh yeah, we're too high. This is one of the easier receivers to adjust. It's a little warm on this side. Let's turn this one down. Now, I was just playing around with the tuner before I turned the camera on, and our FM reception hasn't improved very much. We still don't have stereo. It comes in very reluctantly, and when it does, it's very noisy. And I intend to do a full alignment on this tuner. Let me know down below if you want to watch that on video. It's pretty long and boring, and yeah, I don't know what you guys find entertaining or not. I just stopped trying to guess anymore. So this is good. We're going to leave it there, and we're going to run with this. So now that everything's working, let's do a power test. See, for example, I got 4 bars. It's a very strong signal. No FM stereo. This station, there's no excuse for this. It should come right in. Okay, let's set this up for doing a power test. Turn up the, turn down. Okay, so I have, let me turn the speakers off. Turn our tone on. Okay, there's our tone. Turn up the volume on that. Wrong button. Alright. Turn up the volume. thing's really humming. Well, we're over 100 watts right now. Let's see. Let's do this. Turn this up slowly. Here's our clipping. Back it off. Right about here. Okay. I'm going to hold it there. Start our timer. You can really hear this transformer humming. 27.51 volts RMS on the output. So we'll just wait this out for 10 minutes and see how this is doing. Here's our power consumption, 308 going in. You can hear some kind of sizzling or cracking noise. We're only at the 3-minute mark. Things are heating up. I just don't know where this noise is coming from. This transformer. Transformer is very noisy. Okay, we're coming up to 10 minutes here, and I gotta say I'm impressed with this amplifier. This thing's barely warm. I bet you it's below 50 degrees C. It feels like about 45. What have I got here? What am I measuring here on this side? About 45. This side here, about the same. This load on the other hand is up around 180 C, 190 C. So things are going to start melting there in a minute. Yeah, this thing's built to do the party all day long, all night long. This would be a good amplifier for running 4 ohm loads. I think these oversized heat sinks are really helps it out a lot. So we're going to shut this down. That's one thing I don't like with electronic volume control is look at the steps we're given the choices. So let's turn this down. Let's do our square waves. Alright, so we're at about 1 watt. There's our square wave 1000 hertz tone. Let's go down in frequency and see how it looks. 100 hertz. $90, $80, $70, $60, $50, $40, $30, $20. We got quite a bit of tilt on 20. I think if I replace these input capacitors here, they got some 22 microfarads. I'm thinking of upsizing them to 100 microfarad each, and that would level out that tilt a bit. Let's see here. Let's keep going down. Don't know what the spec is for this amp, but this is 10 hertz. Seem a lot better. Let's go back up. Back to 1000 hertz. Here's treble cut, treble boost, bass cut, bass boost, and then our balance. Controls are nice and clean considering I didn't touch them. Let's go to the high end. $10 kilohertz. 14, 15, 16, 17, 18, 19. Yeah, we're starting to lose it. Starting to lose it around here. It's 23 kilohertz, 24 kilohertz. Not the fastest amp I've ever seen, but hey, I think it's doing okay. Alright, here's a look at some of the parts that went into it. All these Rubicons came out, and these ones are their, I guess these are their version of low noise or audio grade, who knows. different color. These ones mostly are drying up, so there's a lot of them in here that are 4.7 microfarad at 25 volts, and they measure down around 3.8 microfarad, and they're showing their age. These ones, on the other hand, about 90% of these are holding up. About 10% have fallen in value. For example, 100 microfarad might measure out to be about 77, 75 microfarad. So they're drying out as well. So I think this is one of those rare cases when you replace the capacitors, you actually fix the problem in the receiver. And this receiver had nothing but problems, and they were all directly related to capacitor failures, shorted capacitors, or just shorted capacitors. So if you have one of these receivers, I think you want to get these caps out and get some new ones in and prolong its life. Also, there's these caps. So these 3 caps initially shut this receiver down for all intents and purposes. When I did get it powered up again, these 2 were shutting down power supplies. One was in for the tuner, one was for the input selection. This cap here was shorted, and this is in a tape monitor circuit, and that was causing problems there too. So altogether 3 shorted caps. These caps here failed. I don't know why this one failed. This one failed shorted, and this one blew up because it was installed backwards due to incorrect silk screening on the board.
In days gone by, she lived at the ocean.
Alright, so this is going to wrap this one up. I still haven't done the tuner yet. I'm going to do that as separate. If you guys are interested in seeing that, comment down below. That tuner is pretty messed up. It's pretty poor reception, and it's not coming in very good at all. But this thing is, I'm pleased with the outcome of this one. What can I say? It was a boat anchor when it came in, and now it's coming out. It's sounding good. It's looking good. I cleaned up the top. It really looks sexy in this black vinyl wrap. I like that. That's a nice touch, and it cleaned up really well. Okay, so I'm going to finish this one here, and thanks for watching, and take care, and we'll see you on the next one.